Hello everyone. Today we are gonna learn the 10-second trick to find out hybridization. So, without any further delay, let's dive straight into the video. The formula for calculating hybridization is V plus Ma upon 2. Here, V represents the valence electrons of the central atom and Ma represents the number of monovalent atoms surrounding the central atom. Since you are well aware of the formula, so now let's begin with some questions. And the first question is calculating the hybridization of NH3. As here, nitrogen is the central atom and its atomic number is 7, which can be written as 2, 5. The 5 here indicates the valence electron of the central atom, that is nitrogen, and the number of monovalent atom present here is 3. So the formula is 5 plus 3 by 2, that is 4. But since there are only 3 side atoms present here, but the answer comes out to be 4. This indicates that there will be 3 bond pair and 1 lone pair present in case of NH3. And its hybridization will be sp3. So now I want you all to grab a pen and a paper and start doing the questions along with me. Moving on to the next question, which is calculating the hybridization of NH4+. Again, nitrogen being the central atom will have 5 valence electrons present in it and the number of monovalent atoms present here is 4. But since there is a plus sign present, which means it is donating 1 electron, so the formula will be 5 plus 4 minus 1 by 2, which again gives the answer of 4, and the hybridization will be sp3 and 4 bond pairs will be formed. Do remember that hydrogen, fluorine, chlorine, bromine and iodine, they all are monovalent atoms. Next question is calculating the hybridization of XeF2. Since xenon has 8 valence electrons present in it and the number of monovalent atoms here is 2. So the formula is 8 plus 2 by 2, that is 5, giving a hybridization of sp3d. Again, as the answer is 5, but there are just 2 side atoms present with xenon, which means there will be 2 bond pairs and 3 lone pairs present in it. What do you think will be the shape and the geometry of XeF2? Its shape will be linear, whereas the geometry is trigonal bipyramidal. Xenon, being the central atom, will occupy the central position, and the fluorine, being more negative, will occupy the axial position, followed by 3 lone pairs present in the equatorial position. Do remember that the axial bonds are longer than the equatorial bonds, and the axial bonds is generally occupied by the more negative atom followed by less negative atom in the equatorial bond. Now I want you all to calculate the hybridization of SO4 2-. Sulfur has 6 valence electrons present in it, but the number of monovalent atoms present in SO4 2- is 0, as oxygen is not a monovalent atom. Also, it has a charge of -2, which means it is accepting 2 electrons. So, the formula will be 6 plus 0 plus 2 upon 2, which is 4. Its hybridization is sp3 and its shape will be tetrahedral. Now, moving on to the next question, which is calculating the hybridization of XeOF2. Here, xenon, being the central atom, has 8 valence electrons and the number of monovalent atom is 2, because fluorine is a monovalent atom whereas oxygen is not a monovalent atom. So, the formula will be 8 plus 0 plus 2 by 2, which is 5, and the hybridization will be sp3d. Thus, XeOF2 will have 3 bond pairs and 2 lone pairs present in it. What do you think will be the structure of XeOF2? Xe being the central atom will occupy the center position, and since fluorine is more negative than oxygen, so fluorine it will occupy the axial positions, whereas the oxygen and the lone pair they will occupy the equatorial positions. The geometry of XeO F2 will be trigonal bipyramidal, whereas the shape of XeO F2 will be T-shaped. Do remember that in case of the shape, the positions of lone pairs aren't considered. With that, it's a wrap. Thanks for watching and feel free to mention your doubts in the comment section below.